Hello guys, I just want to give you a quick outline again of what's going on. Today's going to be the last lesson. Unfortunately, there's so much on here, it's going to be hard for me to walk you through all of it on the board. So I've printed out great detailed notes and I hope you can follow all of it. Just to let you know, your homework for this is going to be page 638, number 13. Use areas 1, 2, and 3. The reason why I just wanted to show you is this is the problem and this is what you're going to be using. Some people will jump up here because kind of that's how some books do it. But these two go to the same problem in number 13, and that's what you're going to do for your homework. Okay, so what are we going to do today? We're going to do one-way analysis of variance, ANOVA, for comparing three means. I'll let you read this, but essentially what's going to happen is we're going to have three things we want to compare. And the first thing we're going to do is we're going to find out, hey, are these things different than each other? And if so, then we're going to do a second test called the Sheffey test that's going to let us compare each of them and figure out what's going on. For example, average GPA for the swim team is 3.1, volleyball team's 3.25, cross-country team's 2.99. We can see that there is a difference, but we want to know, is there a significant difference to those? So what's going to happen is we're going to walk through and do the same thing we've been doing. We'll have a critical value, we'll have a test value, and I'll show you all that's going to happen. Okay, so the first thing that's going to happen is you're going to have a problem that looks like this. They're going to give us three columns. In this case, you can read the problem, but we want to know, does medication, exercise, or dieting reduce blood pressure in people? First of all, you should know that obviously you should do exercise and diet. If that doesn't work, they'll add an medication. But anyway, what we want to know is if you take a kid and just say, hey, I just want you to take medication, don't change anything else. Then take one person and say, hey, I want you to exercise more. And then one group just to diet more. You do everything else the same. Which one is going to lower your blood pressure the most? Well, you're all smart kids. You can look at this and kind of see, well, it looks like medication actually does. But the question is it significantly different? And then is there a difference between exercising and dieting? So what's going to happen is you're going to have this test, and I gave you a blank sheet so you can kind of walk through it yourself, but then I actually gave you all the answers on here. So you're going to identify the population to be compared, which is the average reduction in blood pressure for each of the three. You're going to assume that they're equal. Remember, we can't just say things are different. So we're going to assume they're equal, and then we're going to try to prove that at least one is different. It's always going to end up being a right tail. So to find your critical value, you're going to use 0.05 unless specified otherwise. DFN is a number you're going to use, and it's going to end up being the number of groups minus 1. Since we're always comparing three things, ours will always be 2. DFD is going to be the sum of all my participants minus K, which in this case is going to be 3 for us. The sum of N is going to be how many people did we have in our study. So in this case, if you count up all these people, there's going to be 14 people. There's going to end up being 17 people, and then when you subtract off 3, that'll give me my 14. Now to find the critical value, we're going to use table H. So table H ends up being a bunch of these tables that look like this. And then what we need to do is find 0.05 up here, which I did that, and it's on 791. So what you do is you use your degrees of freedom of your denominator, which is your DFD, which for us, DFD ended up being 14, so you slide down to 14. And DFN for us is always going to end up being 2, and that's what the numerator is. And so we get 3.74. So I come back here, and that's going to be my critical value. So now to find my test value, I just need to find two numbers. That's called the between group variance and within group variance. The issue is I have to do this worksheet to do that. So if you look up here, before I do anything, I immediately complete my worksheet first. What your worksheet is going to be is it's going to be a blank worksheet that looks like this. For us, it's going to be medication, dieting, exercise. Okay, N is the number, and then what you have to do is you have to put these values in here. So you go to your calculator and you put in 10, 12, 9, 15, 13, and L1. So you go to stats, edit, and in L1 you put these number. Then you go to stats, calculate, and go to one variable stats. And then you put all these things in here. Here's the key. Variance isn't one of your lines. So what you have to do is you have to take SX and you have to square it. When you take SX, please go to 5 decimal places. 5 decimal places and square it. Do the same for the other ones. K is the number of groups, which is 3. This is the sum of however many people took the study. This is the sum of all the X's. This is going to be 3 minus 1. This is going to be the number of however many people the study minus 3. And then we have to figure out these things to get that. So in your packet, I gave you the formula sheet. Sorry I have numbers written on here. But this is the formula sheet. I actually went ahead and wrote the numbers for the example in here. So if you hit one variable stats for that first group, the sum of x's is this. This is 719. This is 11.80 when you round it. Make sure you just follow the directions. All the values round to 2 places. The variance, this is where you take SX and you square it. Make sure you take this to 5 decimals. So make sure you pause this and write on here, take this to 5 decimals. Now, here's the formulas to do these 3. All you do for your grand mean is you take the sum of all the x's you have here, and then you divide it by the sum of n's. Okay, so if you do that, I'll show you, you'll end up getting 7.71. For the sum of squares between groups, this is the formula. So you take N1, and then you take x bar 1 minus xgm. So for each of these, you're going to take the mean and then subtract the grand mean. Square it, take it times n. Just put this in your calculator all at once. And then finally, the sum of squares within group is you're going to take the number of groups minus the number in the group minus 1, and then times the variance for each of them. So you take 5 minus 1 times this, 6 minus 1 times that, 6 minus 1 times that, and then add them together. Then when you get down here, you just use these 2 formulas. Okay? Now, your sheet is going to end up looking like this when you're done, although you'll have all your work in here. So I put actually all the answers on there just so you can check yourself. It's funny, we did all this to get these 2 numbers. So what you do is you come back here and you say, okay, what do I do next? Well, I did all this information. Okay, I found my table. I showed you how to do that. And then I just divide those 2 numbers, and my test value is 10.95, which ends up being in the reject range. So there is a significant relationship in reductions in blood pressure for these different techniques used. So I have it all nice and neat here if you want to try to do it yourself. So the ANOVA test, all it does is it tells us that there's differences between the 2. So then what we do is we use what's called the Sheffey test. So you just start up top, and K is 3 in this case because I have 3 groups. The ANOVA test value was 3.74, which you get that from the page. The within group variance is 6.40, which you get that from your worksheet. All right? And 6.39 is what you probably should have. I just have a 4 marked in its place, whatever it rounds to. Then you put the group's names, you put their means, and you copy that over from your worksheet. Now the Sheffey test value is the ANOVA test value times 2. So that's going to give me my 7.48 here. And then now what I'm going to do is I'm going to compare the 2 groups. So I'm going to compare F1 to F2. So I'm going to compare medication and exercising. So you put it in this formula and just put it all in one. Just make sure, you put this squared divided by parentheses. Just put this in just like that with the parentheses. Hit enter and you get 21.67. So that's way out here. That means there is a relationship or a difference between medication and exercise. That means one's better than the other. So then if I compare 2 and 3, exercise to diet, put it all in this formula, I get 3.32. Well, that means there's not a difference between exercise and dieting. I can't say that one reduces blood pressure better than the other. And then finally, I have X1 and X3. You do it, there's a difference. It's not as big as this one, but it says that medication is better than dieting. Then to make your conclusion, go back to your numbers. And we just proved by the Sheffey test that this is different than these 2. And by looking at the numbers, medication is definitely better at reducing blood pressure than the other 2. And that's the conclusion. Okay, do the best you can. Ask questions. That's the last thing. And please be safe and try to stay out of trouble. Thanks.